Hello, this is Mr. Brooks, and welcome to Lesson 8.4, Sine and Cosine Ratios. In this lesson, we're going to use the sine and cosine to determine side lengths in triangles, and we're going to use the sine ratio to estimate astronomical distances indirectly. Alright, just like tangent is opposite over adjacent, sine is going to be opposite over hypotenuse, and cosine is defined to be adjacent over hypotenuse. Well, let's take a look at some examples and we see if we can figure out what they're talking about. Okay, we're trying to find the sine of angle T. So it's going to be opposite over hypotenuse. So for this one, it's going to be 8 over 17. For cosine of t, adjacent over hypotenuse, so that one's going to be 15 over 17. Sine of g, opposite over hypotenuse, which would be 15 over 17. And the last one for angle G, adjacent over hypotenuse, which would be 8 over 17. Now let's try quick check number 1. Please pause the video while you try to figure out the sine of x and y and the cosine of angle x and angle y. Okay, sine is opposite over hypotenuse. So the sine of x is going to equal 64 over 80. Alright? The cosine is adjacent over hypotenuse. So the cosine of x is going to equal 48 over 80. Now, let's do the sine of y. Again, sine is opposite over hypotenuse. So that's going to equal 48 over 80. And the cosine of y, adjacent over hypotenuse, which would be 64 over 80. Part B on quick check number 1 asks us, does the sine of x equal the cosine of y? Sure enough, it does. And does the cosine of y equal the sine of x? Sure enough, it does as well. And the reason for this is because they are complementary angles. The top of page 440 talks about identities. The way I would explain identities would be for things that are identical, things that are exactly the same. And we're going to try to work on some of the identities from the exercises later. Okay, example 2 is a very interesting example in the use of trigonometry and astronomy because Nicholas Copernicus, who lived back in the 1400s and the early 1500s, determined a way to get the distance of planets closer to the sun than the Earth, how far they were from the sun. Which is pretty amazing to figure this out back when he lived. Well, hopefully you realize that Mercury and Venus are both closer to the sun than the Earth is. So let's take a look at Mercury. Copernicus' way of figuring out how far Mercury was from the sun is first he had to let the planet form a right angle with the Earth and the sun. Now I have no idea how he decided when Mercury was in the right position, but somehow he got Mercury in the right position, forming a right angle with the sun and the Earth. So we got a right triangle. Well, once he does that, he can use his clinometer to measure the angle between the sun and Mercury, and he gets that to be 22.3 degrees. How are we going to be able to figure out x? Please pause the video while you try to figure out x if A is 22.3 degrees. Well, Copernicus decided to let the distance from the Earth to the Sun be 1 astronomical unit. It's approximately 93 million miles, but he just said, okay, let's call that 1 unit. Let's figure out how far Mercury is from the Sun in astronomical units. So we set up the triangle. We're going to use sine because we know the opposite and the hypotenuse. So we're trying to find the opposite, and we know the hypotenuse, and we know the angle measure. So the sine of 22.3 has got to equal opposite over the hypotenuse. We're calling that 1 astronomical unit. So now we just use our trig function. We plug in to our calculator a sine of 22.3 degrees, and we get x to be approximately, all right, this is approximately x, which equals approximately 37 or 0.378 astronomical units, a little over a third the distance that the Earth is from the Sun. All right, quick check number 2 asks us to try to figure out how far Venus is from the Sun in astronomical units. Well, again, we wait until Venus forms a right angle with the Earth and the Sun. E is the Earth, S is the Sun, V is Venus. We measure with our clinometer the angle to be 46 degrees. This distance from the Earth to the Sun, again, is 1 astronomical unit. How are we going to get x? Please pause the video while you try to figure this out. Okay, hopefully you're going to use sine of 46 degrees equals opposite over hypotenuse. Multiply both sides by 1. X is going to be approximately equal to the sine of 46 degrees. We punch that into our calculator and we get x to be approximately 0.72 astronomical units, almost 3/4 the distance from the Sun as the Earth is. Now for part B, they want to know how many miles from the Sun Venus is. We would simply multiply 0.72 times 93 million. And we get approximately 66,960,000 miles. Part B also asks how far Mercury was from the Sun. Well, we said it was approximately 0.38 astronomical units, so we're going to multiply that by 93 million, and we get that to be approximately 35,340,000. 35,340,000 miles from the Sun. Well, example 3 asks us to get the measure of angle L. Well, just like when we were doing tangent, when you're trying to get angle measures, you have to use inverse of your trig function. So on this one, we are going to set up the sine of L equals 3.2 over 4.0. Get my decimal in there. Okay, so L is going to equal the inverse sine of 3.2 over 4.0. So please punch that in, see what you get. Hopefully you got L to be approximately 53.1 degrees. Now let's try it another way. Cosine of L is going to equal adjacent over hypotenuse, 2.4 over 4. So L equals inverse cosine of 2.4 over 4.0. Please punch that in and see if you get the same thing. Hopefully you get 53.1 degrees. The nearest degree it would be 53 degrees for L. Last, we've got quick check number 3. Please pause the video while you try to figure out your angle measures. Again, remember, you're going to use inverse function whenever you're trying to get angle measures. For part A, we're going to say the sine of x equals 6.5 over 10. So x is going to equal the inverse sine of 6.5 over 10. So x is approximately equal to 41 degrees. Hopefully you got it. Now, let's try b. On b, hopefully you agree you will use cosine. Cosine of x equals adjacent over hypotenuse. So x is going to equal inverse cosine of 10/27. And punch that in. Hopefully you would get x to be approximately 68 degrees. This concludes lesson 8.4.